morning students. In a previous class, that is class 1 of the chapter General Metallurgical Operation, I completed the introduction part. What is metal, non-metal, what is mineral, what is ore, what is in free form or native form, in combined form, and the general metallurgical operation. The following steps are, that is, first crushing and grinding. Point 2, concentration of the ore. Point 3, extraction of crude metal from the concentrated ore. Last one is refining. And we discuss complete up to the second point. First one is crushing and grinding, that is known as pulverization of the ore. And the second one, concentration. Different steps. That is gravity separation process, froth flotation process, magnetic separation process, and last one is chemical process or leaching process. And the third one, that is extraction of crude metal from its concentrated ore. It is carried out by two steps. First is conversion of concentrated ore into its oxide form, and it is carried out by two steps, either calcination or roasting. That is completed. Next, today in class 2 of the chapter General Metallurgical Operation, I will try to complete the next step, that means conversion of metal oxide to metal by reduction. Different processes are there. And finally, the refining. So let us start. First one, that means conversion of the concentrated ore into metal by reduction. Mark that. Conversion of concentrated ore, conversion of oxide ore into its metallic form by reduction. There are a few methods are there. That is, point 1, reduction by carbon, aluminium, magnesium, zinc, etc. And next one is, otherwise it is known as chemical reduction. Chemical reduction. Next one is electrolytic reduction. Electrolytic reduction. Next one is self-reduction, self or auto-reduction. Mark that. Generally, 3 different ways are there. One is known as chemical reduction, reduction by carbon, aluminium, magnesium, like this one. Second one is electrolytic reduction, and third one is self or auto reduction. Let us discuss one by one. First one is chemical reduction, bit one is reduction by carbon. Bit 1, chemical reduction. Under this one, point 1, reduction by carbon, otherwise it is known as smelting. The very important one for council point of view. So what is smelting? It is a process of heating the calcinated or roasted ore. It is a process of heating the calcinated or roasted ore with excess supply of air above its melting point. In previous class we discussed already, that is calcination and roasting. Both the cases Strongly heating, one case limited supply, one case excess supply, but both of them possess at heating at lower the melting point, below its melting point. But this one is smelting, heating strongly, excess supply here, but above its melting point. During this, little amount of carbon or coke is added, which is used as an reducing agent, which helps in reduction. During this step, an additional substance is added, which helps to fuse the infusible impurities to form a fusible product. That selective additional substance added is known as a flux, and the finally fusible product is formed known as slag. Mark that. Flux plus infusible impurity give rise to fusible product known as slag. Important question. Define the term flux and slag. Answer. During smelting, selectively additional substance is added to fuse the infusible impurity known as flux. What is a slag? During smelting, after the addition of flux, infusible impurities fuses. That fusible form is known as slag. Again, depending upon the impurity, nature of the impurity, flux is selected. If the impurity is acidic in nature, then basic flux is selected, added. On the other hand, if it is acidic, then basic flux. If it is basic, then acidic flux is added. For example, mark that. Calcium oxide plus silicon dioxide, calcium silicate. Phosphorus pentoxide plus calcium oxide give rise to calcium phosphate. Mark that. It is a basic impurity. It is acidic impurities. It is acidic flux. It is a basic flux, and it is a slag. It is a slag. Mark that. If we observe that basic impurity is there, then we add acidic flux. If we observe that acidic impurity is there, then we add basic flux. In this method, low electropositive metals are reduced by the help of carbon or carbon monoxide. Mark that. For example, lead oxide plus carbon give rise to lead plus carbon monoxide. Lead oxide plus carbon monoxide give rise to lead plus carbon dioxide. Similarly, ferric oxide plus carbon give rise to iron plus carbon monoxide. Ferric oxide plus carbon monoxide give rise to iron plus carbon dioxide. Mark that. These are some common examples under the heading of reduction with carbon or smelting. Move to the second one, that is reduction with aluminium. The second step, that is reduction with aluminum. Otherwise it is known as aluminothermy. Some metals are there like manganese, chromium, having high boiling points. Their oxides are generally not reduced by carbon. For that cases, aluminum is selected as a reducing agent. The process of reduction of a metal oxide carried out with aluminum is known as aluminothermy. Generally, chromium, manganese, they are reduced from their oxide by the help of aluminothermy. For example, Cr2O3 plus Al give rise to chromium plus Al2O3. Manganese oxide Mn3O4 plus Al give rise to manganese plus Al2O3. Mark that. The chromium and manganese of metals having high melting point are generally not reduced by carbon. So their oxides are reduced by aluminum and the process is known as aluminothermy. Move to the next one, that is electrolytic reduction. Next one is, that is electrolytic reduction. Some highly electropositive metals like sodium, potassium, calcium, magnesium, aluminum, generally not reduced by carbon, because this process is not going on by carbon because they combine with carbon to form corresponding metallic carbide. So these are reduced by the electrolysis process. A suitable electrolyte is selected. Here, pure metal acts as a cathode while impure metal acts as a anode. And the respective metal salt solution are taken as the electrolyte. At cathode, reduction takes place, pure metal get deposited at the cathode, while equivalent amount of metal from anode dissolve into the electrolyte. Move to the next one, that is hydrometallurgical process. Next one, hydrometallurgy. The principle of this process is that a more electropositive metal displaces a less electropositive metal from its salt solution. I repeat again. The basic concept of this process is that a more electropositive metal displaces a metal of lower electropositive from its salt solution. In this way, the metal having lower electropositive is displaced from the solution. For example, mark the equation. Silver sulfide plus sodium cyanide give rise to sodium argentocyanide. Its name is common name sodium argentocyanide. Next, sodium argentocyanide treated with zinc to form that is sodium tetracyanido zincate. To mark that here, zinc displaces silver from its salt solution. It is more electropositive metal, displaces less electropositive metal from the salt solution. It is known as hydrometallurgy. Next, move to the another process that is known as self-reduction or auto-reduction. Next one, self-reduction or auto-reduction. The principle of this method is less electropositive metal oxide is strongly heated with a current of air to form its oxide form. I repeat again. The sulfide form of less electropositive metal heated strongly with a current of air to form its corresponding oxide form. That oxide form again combines with remaining sulfide form, undergoes self-reduction or auto-reduction, resulting in the formation of a metal. As in this process, no reducing agent is added, they undergoes reduction itself, so it is known as self-reduction or auto-reduction. Suitable example is reduction going on in case of metallurgy of copper. Mark that. Copper pyrite CuFeS2, that is known as copper pyrite. On oxidation give rise to Cu2S plus Fes plus SO2. Then copper sulfide converted to copper oxide. Ferrous sulfide converted to ferrous oxide. Then the copper oxide combined with the remaining of copper sulfide undergoes self-reduction to form copper plus sulfur dioxide. Mark that. As no extra reducing agent is used, so that's why it is known as self-reduction or auto-reduction. Then another one is there, that is the reduction going on by hydrogen or water gas. Next one is 6, reduction by hydrogen or water gas. Hydrogen gas is a better reducing agent. Hydrogen gas is a better reducing agent, but it is used limitedly. Its use is very much limited because of its expensive nature. However, tungsten, nickel, they are in oxide form is reduced by the hydrogen or water gas. Mark that. Tungsten oxide plus hydrogen give rise to tungsten plus water. Nickel oxide plus hydrogen plus carbon monoxide give rise to nickel plus carbon dioxide plus water. Mark that. Tungsten oxide and nickel oxide is reduced by the hydrogen or water gas. These are some common method of reduction. So step 1 is concentrated ore converted to oxide form. Next is oxide form transferred to metallic form by reduction. Then last one is refining. The last step of the general metallurgical operation is refining. The different metals reduced by the different process are not pure except electrolytic reduction. Therefore, it is necessary to remove the impurities from its crude metal. The process of removing the impurities from crude metal is known as refining. I repeat again. The process of removing the impurities from crude metal is known as refining. Depending upon the nature of the metal and also depending upon the impurities, I repeat again, depending upon the nature of the metal and also the nature of the impurities, different purification, different refining processes are there. Some examples are distillation, liquidation, electrolytic refining, vapor phase refining, vapor phase refining again is of two types. One is Mond process, Van Arkel method. Next, zone refining. And last one is advanced method, that is chromatography. Mark that. Some important step processes are there for the refining, that is distillation, liquidation, electrolytic refining, vapor phase refining. It is carried out in two different ways. One is known as the Mond process. It is meant for extraction, purification of nickel. Van Arkel method, it is for the purification of ultra pure metal, titanium, zirconium. Then zone refining, and last one is chromatography. Let us discuss one by one. First one is distillation. This method is meant for the metals having volatile metals having non-volatile impurities. That means like zinc, cadmium, mercury having low melting point, volatile metals possess non-volatile impurities. On heating, strong heating, metal volatile remove while leaving behind the non-volatile impurities. Move to the next one, that is liquidation. What is liquidation? That is low melting point solid metal that are easily fusible while impurities remain as such. Like lead, tin, mercury. Mark that metal along with the impurities when heated in a slanting crucible, then upon heating, the metal liquefy, flowing down while leaving behind the impurities. Next one is electrolytic refining. Very, very important one, electrolytic refining. Suitable electrolyte is selected while at that time the cathode is selected as a pure metal while anode is impure metal. At that time, suitable another substance is added in order to lower down the melting point of the electrolyte as well as increases the conductivity. The most important thing mark that during electrolytic refining, pure metal act as a cathode while impure metal act as anode. For example, let us consider while electrolytic refining of molten sodium chloride. Sodium is collected at the cathode while chlorine is collected at the anode. Mark the equation. Molten sodium chloride fuses to form Na plus Cl minus at cathode. Na plus electron give rise to Na, and at anode Cl minus electron give rise to Cl, Cl plus Cl give rise to Cl2. Metal, sodium metal is collected at the cathode while chlorine gas is liberated at the anode. Move to next one, that is a vapor phase refining. The principle of this process is that the metal first converted into a volatile compound by reacting with another substance at a low temperature, and the volatile component decomposes at high temperature to break down its original metallic form. And this is carried out in two steps. One is known as Mond process and one is known as Van Arkel method. In Mond process, nickel is purified by Mond process. So here, nickel is heated with carbon monoxide to form a volatile intermediate, nickel tetracarbonyl, which is then strongly heated to decompose the nickel. Mark the equation. Nickel plus carbon monoxide 330 to 350 Kelvin to form tetracarbonyl nickel 0 or nickel carbonyl, and upon strong heating, that is 450 to 470 Kelvin, form, it is known as impure nickel, impure form, and it is known as pure form. It is known as Mond process. This is known as Mond process. Mond process. Very, very important one mark question. That is Mond process meant for the purification of which metal? Answer is nickel. B2 is Van Arkel method. Same principle is that, but here the highly purified form, ultra pure form metal, that is titanium, zirconium, is obtained by heating with iodine to form unstable volatile form, then upon high temperature decompose to pure form. Mark the equation. Titanium heated with iodine to form volatile intermediate form. Again upon heating strongly to form titanium plus iodine. It is known as impure form. It is known as pure form. Similarly, one more question is there. Titanium and zirconium is purified by which process? It is a multiple choice question. Answer is Van Arkel method. Concept based upon the vapor phase refining. Metal converted to volatile impurities on heating. Again strong heating decomposed to its pure form, pure metallic form. Next switch over to zone refining. Next is next method is zone refining. Otherwise, it is also known as fractional crystallization. The principle of this process, the fundamental principle of this process is that the impurities always a strong affinity towards in molten form, liquid form, while the metal remain in solid form. Mark that. What happened? A metal rod is there, around with a circular mobile heater is there, on heating, and that metal rod in the sloping form, on strong heating, start to melt. When it is melt starts, the mobile heater move forward. At that time, the pure metal solidify, while the impurities move from one end to higher to lower end. Again, this portion, again heated, then the impurities in molten form move down the bottom, while the pure metal solidify. In this way, by fraction, by heating, pure metal solidify, while the impurity has strong affinity to form in molten form. And finally, it is removed. It is known as zone refining or fractional crystallization. And the last one is, that is chromatography. It is a modern method, recent method, which is based upon the concept of adsorption, which is, last one is chromatography. This method is based upon the concept of adsorption. Two different words, never confuse. One is known as absorption, mark that. One is known as absorption. One is known as adsorption. In simple word, it is known as surface phenomena. Chemical reaction carried out on the surface only. It is known as bulk phenomena. Means chemical reaction going on throughout the system. So, this chromatography based upon the adsorption, different adsorption of the solution to different extent. And it is the modern method. These are the different steps followed during the refining. And it is all about the steps followed during the extraction of metal from its ore or general metallurgical operation.